How's it going, everyone? Do you have any questions on anything before we get started? Oh, yeah, I was looking at that a minute ago. The homework that I originally assigned for section 1.5 weeks ago. Um, don't worry about it. I changed it to where there's no late penalty, and I'm still like some of you have already done it, which is good. I'm not sure how you figured out how to do that, but anyway, row echelon, reduce row echelon form. Yeah, yeah. Don't worry about the homework so much. Um, I'll get them formally assigned eventually. Anyway, so y'all are in chapter 6 then, huh? Okay. Yeah, I do need to grade y'all on something for this class, but part of it is attendance, so that's good. Okay, we're on page 285. This is section 6.2. Let's see. Um, now, what type of matrices are you working with? Three equations with three variables, or are you going up to four variables, or what? I'm just curious what I should try to focus on here. Three by four. The fourth one being the equals two part. I imagine that's what you mean. Yeah. 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 Okay. So that's what I'll focus on when we talk about it here, because I'm looking at the textbook and there's some other ones besides that. I don't want to confuse you if that's not what you're covering. So, um, let's see. I'm going to start off, this is page 285, like I said. And we'll start off with 30. Well, this is, no, sorry, this is a stupid question. Oh well, we'll do it anyway. All the numbers are zero, so that means, well, at least there's one solution. Really, the emphasis on this problem, that's not a stupid question, but I think it's a silly question. That's probably a better word for it. When everything's equal to 0 on the right-hand side, that means our answer is x equals 0, y equals 0, and z equals 0. So there's really nothing interesting about the answer, but it's really the process that we want to focus on, and that's actually what you're talking about, is just working with reduced row echelon form and how to get there. So we set up our matrix initially. And I like to draw a line between where the equal sign would be, basically. So 1x, 2y, 1z equals 0, so 1, 2, 1, 0. There's no x, 1y, 2z equals 0, 0, 1, 2, 0. 1x, 1y, negative 1z, and then 0, so 1, 1, negative 1, 0. Probably everyone's okay with how we set that up. Now, the order that we generally go in for a reduced row echelon form is you always want to get a 1 in the upper left first. And after we get a 1 there, we want to get zeros beneath that. So always handle the first column first. Next, once that's taken care of, we move to the second column. We want to get a 1 here in the middle with zeros above and below. And after we take care of that, we move to the third column, get a 1 right here in the bottom right with zeros above. Okay. Yeah, so we get a 1 here, 0 out the other two, 1 here, 0 out the other two, and then 1 here, 0 out the other two. That's kind of the process that we want to follow. Now the operations that we have available to us one, we can switch 2 rows. 2, we can multiply a row by a number. And when we say multiply, it actually includes dividing. In 3, we can add or subtract one row to another. Now when we say we can add or subtract one row to another, we could also do that, add or subtract a multiple of one row to another. Now one thing that I like to do as I go through this the matrix solving process is to make sure I record each of my steps and showing what operations have taken place from our available operations here. Now notice in this particular matrix we start off with a 1. we start off with a 1 in the upper left already. So that's our first goal, is to have a 1 there, so we know that we're already successful at that. And then once we get this 1 here, we want to make both of these 0. This one's already a 0, we don't have to mess with that. But we need to zero out this term here. Okay? And the way that we can zero out that term is by taking row 3 and subtracting row 1. So my notation, and I don't know what kind of notation Mrs. Knisley used. The notation I usually use is row 3 minus row 1 becomes the new row 3. Okay. Is that similar to what y'all have seen already, or have you done a lot of that in class? Similar? The main thing is, can we understand this? So you just started yesterday. Okay, that's fine. That's fine. So what I'm saying we want to do is we want to make this a 0. We can make this 0 by subtracting this 1 from it. So I'm saying if we take row 3 and subtract row 1, we'll make that the new row 3. Now, the only row that we're changing is row 3. So first thing we'll do is make sure we write down row 1 and row 2, because those have not changed. Now row 3 minus row 1, so that's 1 minus 1, 1 minus 2, and negative 1 minus 1, and 0 minus 0. Okay. So we took each of these values on row 3 and subtracted the value from row 1. So 1 minus 1, 1 minus 2, and negative 1 minus 1. And then we write down the results here on our row 3. So our first column is now where we want it to be. We want it to be 1, 0, 0. Now, the second column we want to be, well, I'm going to run into some other problem here, but anyway, the second column we want to be 0, 1, 0. Because our goal is to, let me move this up. Our goal is to get to the point where we have an expression such as this, where we reduce the left-hand side, where we just have 1s on the diagonal and 0s everywhere else. And then whatever numbers are over here, then x would equal a, y would equal b, and z would equal c. So this is what we try to work towards. So we do it one column at a time. We get the first column where it needs to be, then the second column, then the third. Okay, so we have the first column where we need it to be. Now, next we want to work on the second column, which means we want a 1 in the middle. Well, we already have that right here. We have our 1 where we need it, and so let's use that to cancel out the 1 below it. So we want to make this one a 0 next. So how can we make this value a 0? Well, if we just add those two together, that'll make it a 0. So let's take row 3 and add row 2 to it, and that'll give us a new row 3. Now again, we have not changed row 1 or row 2. We can just rewrite them. We are changing row 3 though. We're just adding these two values, row 2 and row 3, together. So 0 and 0 is 0. 1 and negative 1 is 0, which is what we want there. Now 2 and negative 2, this also gives us a 0, and we have a 0 here. Now what happens is we got a row of zeros. Anytime we end up with this situation where we have a row of zeros, that tells us that the solution is what's the word for it? They have the correct language in the book. Independent, dependent, or inconsistent. It's a dependent system when we get a row of zeros. Okay. Now, if this had not been a zero here also, if this had been something besides zero, like right here specifically, then we would have kept going with this process. But once we get to a point, if we ever get to a point where it's just all zeros here, and if this is also a zero, then it's dependent. If we have three zeros and a number besides zero, then it's inconsistent in that case. Okay, which I'm sure will come up in one of these examples. So let me find one that actually has a solution, and we can work through that in a little bit more detail. So this one, once we get to this space, we can just stop, and what this tells us, we're not going to be able to find a solution. In fact, it's a dependent system, which means there's actually infinite solutions to this. Okay. So let's look at, not that one. Let's look at 34. So for 34, and I'll move the paper in a moment, so please bear with me. 2x plus 2y plus 2z is equal to 6. 3x minus 3y minus 4z is equal to negative 1. And x minus y plus 3z is equal to 11. Now, our goal, once again, our goal is to achieve a matrix that looks like this, where ones in the diagonal, zeros everywhere else, and then our answer is on the right. And that's what's called an independent solution. We want to get an independent solution if possible. Alright, so we make our matrix first. Two, 2, 2, 6, 3, negative 3, negative 4, negative 1, 1, negative 1, 3, and 11. Okay, ignore that. So that's our matrix. So again, the first thing we want to do is get a 1 in the upper left. There's actually different steps we can take to make that happen. One of them is going to be easier than the others, so I'll save that one for last. But one thing we could do is we could take row 1 and subtract row 3. 2 minus 1 would give us a 1 right there. We could also take row 2 minus row 1 and put that in row 1 as a result, and 3 minus 2 would give us a 1. But probably the easiest thing, since all of these numbers are even to begin with, We could just take this row 1 and divide everything by 2, and that would also give us a 1 in that first position. I think that's the easiest way to go because it only works for that one row. That only affects that one row, I guess. So we can take row 1 divided by 2 and replace row 1 with the answer. One, 1, 1, and 3. Then the other two rows do not change, so we'll just rewrite them. Okay. Usually I like to draw an arrow there to show that's what it becomes. Also, I usually have more room than that, sorry. Once we have a 1 here, we want to zero out these two terms that are below it. So let's take this 3 that's here, we want to make that a 0. And we want to use the 1 that we just created, generally speaking. Now, for that, we can take row 2, and we need to subtract row 1, but the question is, what do you mean by some equations, Brandon? Mainly when we're working with systems of equations, this is when we apply this. Oh, yeah. Linear equations specifically, so they all have to be raised to the first power. If any of these are squared, then we can't do it. Okay. Alright. We have a 3 here, and we want to take this 1 and make that a 0. So the question is, how many times do we have to subtract 1 from 3 to make it 0? Well, we know we can subtract 1 3 times, so 3 minus 3 would be 0. So if we take R2 and subtract 3 times row 1, yeah, then we'll replace that with row 2, or replace row 2 with that result. So again, we have a 3, and we want to make it a 0, so we want to subtract 1 3 times. So if we take 3 times this row, that'll give us a 3, and then 3 minus 3 would make that a 0. Now, we're only working with row 2 here. So row 1 and row 3 are unchanged. Now we took 3 minus 3 times row 1, so 3 minus 3 times 1, 3 minus 3, 0. Negative 3 minus 3 times 1, negative 3 minus 3, negative 6. Negative 4 minus 3 times 1, negative 4 minus 3, negative 7. And negative 1 minus 3 times 3, negative 1 minus 9, negative 10. One of the real issues working with matrices is just the sheer number of opportunities to make a mistake, to be honest. And so this is where we have to be very precise with our arithmetic and our calculations. Once you get a little more comfortable, you can do this step and the next one in the same change, but I like to do it one at a time when you first start learning these things. So we got this to be a 0. Now we want to zero out this number down here. So to make this 1 a 0, we just need to take row 3 and subtract row 1. Because 1 minus 1 would cancel out to a 0. So we're going to take row 3, we're going to subtract row 1, and then we'll replace row 3 with the result of that operation. So we're only changing row 3 here. So first 2 rows we can just rewrite them without we knowing that they haven't been changed. But we're altering row 3, so row 3 minus row 1. So 1 minus 1 gives us 0. Negative 1 minus 1, negative 2. 3 minus 1, 2. And 11 minus 3, 8. Well, the alternative is we have a graphing calculator that handles matrices. Well, it doesn't even have to be graphing. I think some of your smaller scientific calculators will also do matrices. Otherwise, yes, it's a half hour reducing these things. With a little practice, you get it faster than that, but starting out, it's really a slow and arduous process. All right. So after 3 steps, we have the first column where we want it to be. First column is 1, 0, 0. So now we look at the second column. For the second column, we want to start off with a 1 in this location. Now, when we say we want a 1 there, we don't have to necessarily use that row. We could use row 3 instead of row 2 if we think it'll be easier. In fact, in this case, I think working with row 3 will be easier. So what I propose is that we can... Well, here's my thinking. I want to explain this to you before we start doing stuff. How would we take this negative 6 and make it into a 1? Well, we can add this 1 to that 7 times, because 7 added to the negative 6 would make it a positive 1. But here's the problem. If we start adding row 1 to row 2, we're going to change this 0 that we already worked so hard to make a 0 in the first place. So once we get the first column straight, we don't want to use row 1 for anything. So we just want to work with row 2 and row 3 and get a 1 right there. Now we think about how can we add negative 2 or subtract negative 2 a number of times from negative 6 and come up with a 1. Well, it's an even number, so that doesn't really work that well. The alternative is looking at negative 2 instead. If we look at negative 2 instead and we think, okay, how can we make this a 1? Again, working with the negative 6 and negative 2, since they're both even numbers, it's going to be difficult to help them work together to make a 1. But individually, we see that all the numbers are even on row 3. So we can take row 3 and divide everything by negative 2. And that would make that a 1. Okay? That's probably the easiest way. We can't do that with row 2 because if we divide everything by negative 6, we make a whole bunch of fractions happen. Now, we could work this with fractions, but no one really wants to do a matrix with fractions. So we're just trying to work around that. So what I'm going to do is take row 3 and divide by negative 2. Now we're only working with row 3. Yeah, we have to do the same thing to every number on that row. Now we're only working with row 3. So let's divide 0 by negative 2, which is 0. Negative 2 divided by negative 2 gives us the 1 that we wanted. 2 divided by negative 2 is negative 1. And 8 divided by negative 2 is negative 4. Now from here, since we wanted a 1 in that middle, not on the bottom, let's just switch row 2 and row 3. And the notation there is the double arrow, so showing that the two rows switch. So for row 3, we put that on row 2. Row 3, write that down here. Okay. Now, we have a 1 in the middle, like we wanted. Now we want zeros in both of these locations. We want a 0 above it, and we want a 0 below it. And we'll use that 1 to make that happen. Let's go ahead and try 2 steps at once. How can we use row 1 and row 2 to make that a 0? Well, since they're both 1s, then that means we just need to subtract them, right? Now we have to be careful of the order of subtraction in this case. We want to leave this as a positive 1. So we'll start with R1 and then just subtract R2. So take row 1, subtract row 2. That'll cancel out this, so be a 1 minus 1 would give us a 0 there. Now we want to do the same thing on row 3. For row 3, though, we start with a negative 6. And that means we'll have to add 1 to it 6 times to make it a 0. As we know, negative 6 plus 6 times 1 would equal 0. So we'll add row 2 6 times, and that'll be our new row 3. Okay, because that'll give us negative 6 plus 6 times 1 is 0, and that'll make it a 0 here as well. So we get 0 and 0 above and below our 1. Now the only row that we're not changing in this step is row 2. Row 2 remains the same. We're using it to change everything else. So row 1 minus row 2 replaces row 1. So row 1 minus row 2. So 1 minus 0, 1. 1 minus 1, 0. 1 minus negative 1, 2. And 3 minus negative 4, 7. Now we also look at row 3. Row 3 we want to add 6 times row 2. So negative 6 plus 6 times 1. Well, sorry, 0 plus 6 times 0. That is a 0 still. Negative 6 plus 6 times 1, negative 6 plus 6 is a 0, as we intended. And then negative 7 plus 6 times negative 1. So negative 7 minus 6 is negative 13. Negative 7, okay, we did that one. So negative 10 so what do we do to this set as it's applied to a graph? It's hard to really compare this to working with a graph. One of the issues is we're not really familiar at this point how to work with a graph in 3 variables. That's not something we learn until 3rd semester calculus, and not like business calculus means actual calculus. You won't ever have to worry about the graphing aspects here, if that's any consolation. But yeah. These equations we're working with actually describe a plane in 3 dimensions. And so we're basically finding the one point where all 3 planes intersect. Okay. What we're actually trying to do here is find a value, and let's look at the original equation. We're trying to find a value for x, y, and z where all 3 of these equations yield true statements. Okay? So is there a value for x, y, and z where 2x plus 2y plus 2z equals 6? Certainly there's a lot of values where that's true. And there's a lot of values where 3x minus 3y minus 4z is equal to negative 1. And a lot of values where x minus y plus 3z equals 11. But we want one coordinate, or one combination of x, y, and z where all 3 are true simultaneously. Okay? And that's ultimately what we're trying to find in solving this system of equations. Trying to think of this from an application standpoint. Like, what could we be actually finding here? And honestly, the examples they give are not a lot of help. The one example they give is concert tickets down here. A band concert is attended by X adults, Y teenagers, and Z preteen children. These numbers satisfy the following equations. How many adults, teenagers, and children are present? Okay, that's not a great example. It's not often we use 3 equations with 3 unknowns, and I assume there's business applications, otherwise it wouldn't be in the textbook. And it could be a situation where no, all the situations I can think of are like constructed based on things we should already know, not what we're trying to find. And it may be that there's applications I'm not aware of that apply to business that don't apply to in my own education, which is more focused on engineering applications and physics applications. The systems of equations in general are useful, but with 3 variables and 3 unknowns specifically, I don't know. I'm sure there's an application for it, I'm just not aware of it, unfortunately. Oh, sorry. Well, we weren't quite done anyway, Brenda. Let's finish this problem first, then we'll look at some technology solutions. Let's see, so negative 7 plus 6 times negative 1 is negative 7, and negative 6 makes negative 13. So we got, so the last one here, R3 plus 6R2, so negative 10 and 6 times negative 4, so negative 10 and negative 24 is negative 34. Oof, that's bad news. Not bad news, but it's kind of bad news. Let's see, negative 10 and negative 24 is negative 34. I didn't make a mistake there. This one just has weird answers, apparently. The issue is that I'm looking at in this problem is once we want to make this last term 0, the only tool that we have at this stage to make that 0, or to make that 1, sorry, without changing any of our other parts here that we already got where we wanted to be, our next step is just to divide this third row by whatever number is here. And unfortunately 34 is not a multiple of 13. So it means we will have a fraction. So not great. We'll push through as we can. Now, taking negative 34 and divided by negative 13, since we have a negative divided by a negative, at least that becomes a positive, but unfortunately it doesn't reduce any further than that, so I'll leave it as 34 over 13. Okay. Alright. So we got that taken care of. That's now a 1, as we needed. So we have 1s in the diagonal, 0s beneath them. So this is already what we call upper triangular. I don't know if that is any terminology that Joe learned. But we now need to zero out the two terms above our 1. And that'll actually be our last step, thankfully. Now to make this one a 0, we just need to subtract these two rows. So we'll do row 2 minus row 3, and that'll give us the new row 2. And for row 1, we have a 2 to begin with, so we'll have to subtract 1 twice. So we'll do row 1 minus 2 times row 3, and that'll make our new row 1. So we're only leaving row 3 alone. The other rows are changing. So row 2 minus row 3, so 0 minus 0, 1 minus 0, 1 minus 1, 0, and then negative 4 minus 34 over 13. I'm actually going to use a calculator for that. Negative 4 minus 34 over 13. That is negative 86 over 13. And with row 1, we want row 1 minus 2 times row 3. So 1 minus 2 times 0. 1 minus 0 is 1. 0 minus 2 times 0. 0 minus 0 is 0. And then 2 minus 2 times 1. 2 minus 2, 0. Then more importantly, 7 minus 2 times 34 over 13. So that's 7 minus, in parentheses, 2 times 34 over 13, which gives us 23 over 13. So x equals 23 over 13, y equals negative 86 over 13, and z is equal to 34 over 13. Granted, this would be much easier if we had gotten whole number answers, but that's what we end up with. Now this calculator won't do matrices. I know my graphing calculator will. I'm going to check my smaller calculator though. Yes. This calculator has a matrix button here. So we put second and then matrix. So edit. A, we have 3 rows. 3 columns. No, it's not going to quite do what we want there. Let me try something real quick. No. We still have to enter the matrix into the... Alright. I don't know if that's going to work. So instead, this guy. Seriously, you have 30 of those? That's a nightmare. Oops, this is actually 3 by 4, my bad. Alright. So first row is 2, 2, 2, 6. Second row is 3, negative 3, negative 4, and negative 1. And third row is 1, negative 1, 3, and 11. So we got everything entered in. Second matrix, math. We want the row reduced echelon form. There we go, B. And that's matrix A. Let's see, where's that letter A? go. Hmm. Hmm. Week 6 practice is 30 questions. Wow. I think the issue is I'm not quite sure how to do this on the calculator. I was able to enter the matrix okay, but it should be able to reduce it for me. But really, I just wanted to check if did it work correctly. Well, it's giving me invalid dimensions for everything because it's a 3x4 rather than a 3x3. I know there's a way to solve it. I just don't quite remember how. Really? That's awfully optimistic of her. Theoretically, it's easier to work on the calculator if you know how to operate the calculator. Turns out I'm not real familiar with solving these on calculator. But there is a way to do it if you have instructions with your calculator and you see like you have a matrix button or something. Yeah, that's exactly the problem right there. Let me create a little bit easier question that doesn't have fractions. I think that'll be nice. Okay. We don't have a calculator course, no. That's something we usually, kind of teach in our class as we go along. If she doesn't intend for you to use it, if she intends for you to use a calculator, I think she would show you how to use it on the calculator. I think she intends for you to do it by hand, which is the whole point here. If it's only two equations with two variables, they're real easy. It's the 3x3s that are really hard. Because the work just gets exponentially more involved the more dimensions we have. So. Okay. Now we go ahead and create our matrix for this system. So 3, 1, 2, 2, -1, -3, -1, 3, -2, and then 6, 2, and 14. Okay. I think everyone's okay with that step, right? We create our augmented matrix just by translating, basically leaving off the variables here. So we look at this matrix. What's the easiest way to get a 1 in the upper left corner? Does anyone have an idea? How we can get a 1 in the upper left corner? You can take row 1 and subtract row 2 twice, yeah. Here's another way that might be a little bit easier. And I think the easier way is actually just, we already have a 1 right here. We could just switch those two rows. So if we switch row 1 and row 2, that'll put the 1 in the upper left. Now remember, we want to start off with a 1, not a 0. Okay. So look, we'd actually multiply by -2, not -3, if we wanted to do that. Additionally, we could also say row 1 minus row 3. Yeah, that's fine. I mean, we're just diving into this. Trial and error is important. I think switching row 1 and row 2 is the easiest approach when possible. So they'll put 1, -1, 3, and 2. Row 2 goes first. That's a 2, sorry. And then row 1 is now second, so 3, 2, -1, 6, and row 3 is unchanged, like so. We have a 1 here. Now we need to make both of these rows zeros. So how are we going to take row 2 and make that a 0 in that first position? Hmm. We don't want to work with these two together. What we want to do is we want to take the row 1 and use that to make this 0, and then use that to make this 0. Y'all see what I mean? So multiply row 1 by -3 and subtract. So we'll take row 2 minus 3 times row 1. So 3 minus 3 times 1 will give us a 0 for row 2. And if we want to put a 0 here at the bottom at the same time, how would we make this 2 into a 0 for row 3? So we want to minus 2 times row 1 and add that to row 3. Yeah. So we'll take row 3, which is a 2, subtract 2 times row 1, which is a 1. So 2 minus 2 times 1 will be 0. And we'll put that in the new row 3. Now again, we're choosing the steps to use based on these first numbers, needing them to be zeros. So we always have 1, 0, 0 on our first column. But at the same time, whatever we do for the first column has to be applied for the other 3 columns. And that's the other thing that we want to make sure we get right. So the only column, or the only row we're not changing is row 1. But we are changing row 2 and row 3. So for row 2, we're taking row 2 minus 3 times row 1, and that'll be our new row 2. So row 2, 3, minus 3 times row 1, 1. 3 minus 3 times 1, 3 minus 3, gives us a 0, as we wanted. 2 minus 3 times -1, 2 plus 3, because -3, -1 is positive 3. So 2 plus 3 will make a 5 here. -1 minus 3 times 3, -1 minus 9, -10. And then 6 minus 3 times 2, 6 minus 6 will give us a 0. So that takes care of row 2. Now for row 3, we said row 3 minus 2 times row 1 is row 3. So 2 minus 2 times 1. So it's a row 3 is a 2, row 1 is a 1. So 2 minus 2 times 1, 2 minus 2, gives us the 0 as we wanted. -3 minus 2 times -1, -3 plus 2 is -1. -2 minus 2 times 3. So negative 2 minus 6 is negative 8. And then 14 minus 2 times 2. 14 minus 4 gives us a 10. Okay. So having done that, we now have the first column exactly where we want it to be, 1, 0, 0. Now we work on the second column. Our goal for the second column again is we want 0, 1, 0. But we always want to get our 1 first before we try to get our zeros after that. So the next question is, how are we going to make either of these two numbers into a 1? There's several ways that we can achieve that. I see 3 ways right off how we can do that. Again, keep in mind there are 3 different operations, row operations, that we can perform. 1, we can switch 2 rows. 2, we can multiply or divide a row by a number. And 3, we can add one row to another, or a multiple of one row to another. So the first way that I see that we can get a 1, is we can just switch these 2 rows and then multiply this row by a negative 1 to make it a positive 1. The second way that I see is we could just, since these are both multiples of 5 on row 2, we can just take each number in row 2 and divide it by 5, and that'll make that a 1, and this will still be a whole number, which is nice. And the third way is we can just take like row 2 plus 4 times row 3, and that'll give us a 1 also. But I think the other 2 ways are easier. So let's go with what Mary suggests, which is to switch. So we'll switch row 2 and row 3. So row 2 becomes row 3 becomes row 2. And now we're almost there, except to get this to be a 1, we still need to multiply that whole row by a negative 1. So we'll say negative 1 times row 2 will be our new row 2. I need a little more space. And so multiplying each of these numbers here by negative 1 with 0, 1, 8, and negative 10. The only quicker way would be calculator, like I said. It's kind of a lengthy process, unfortunately. Yeah. Now she may show you how to do it on a calculator. Yet, if you've only just started this section. So maybe that's something y'all can ask her to try to show you all tomorrow in class, or email her about. Otherwise, if we're doing it by hand, this is the the fastest way, unfortunately. It's still kind of a problem, I imagine. But yeah. Yeah, definitely. Let's see. Switch, multiply, and add and subtract. That's correct, Mary. The available option is pain. Also accurate, it turns out. Yeah, by and large, this is one of the least popular things that you probably do in this class right here. Division is actually a form of multiplication, so I kind of grouped them together, but multiplication and division are kind of the same thing in this regard. So if you want to think of it as multiplication and division by a number on a row, that's possible. That's another way to say it. Yeah. Okay. So we have 1, 0, 0, like we want. We have 1 in the middle, like we want. And now we need to make both of these numbers into zeros. I know, I forgot you'll have to do this stuff when we were talking about the other stuff last time, so I apologize for that. I didn't think y'all did this much with matrices in this class, but if you do, yeah. Well, I mean, after you get through all this stuff, and then you do like linear programming, then you have, I think you have logarithmic and exponential functions. It depends how you feel about those, but I think they'll be easier than this. So yeah, this is as bad as it could possibly be this week. hopefully, hopefully it won't be any worse, but you never know. I'm pretty, being familiar with the material for this subject, matrices is about as painful as it gets. Yeah. So we have row 2 set up with our 1. Absolutely, that's an option. If you want to find someone to tutor you, that would be great. I mean, you're always welcome to message us, Mrs. Knisley and myself, but sometimes it's nice to have another perspective. Yeah, and which is the other issue. Now we do have the math lab. The math lab is open in certain hours during the week. I'm not quite sure on what the hours are, but not everyone I know is willing or able to go there in person and get tutoring. Yeah, that's free at least, although technically it's not free. But basically, you've already paid the fee when you registered for class, so it's no more money than you've already spent at least. So how are we going to make this -1 into a 0? but specifically. They haven't. I haven't been able to get her to acknowledge my emails, so it's a whole thing, Brent. Yeah, don't worry about that one. Don't worry about that one. Alright, we want to make this into a 0, and we have a 1 here and a negative 1 here, so if we just add those two together, we should be able to make that a 0. So we're going to take row 1 and add row 2 to that, and replace row 1. And for row 3, we have a 5 right here. And we want to use that 1 to make it a 0. So if we take the 5 and subtract 1 5 times, that should do the trick. So we'll take row 3 and subtract row 2 5 times and replace row 3. So for row 1 plus row 2, replace row 1. 1 plus 0 is 1. Negative 1 plus 1, 0. 3 plus 8, 11. And then 2 plus negative 10 is negative 8. For row 3, we wanted to subtract 5 times row 2. So 0 minus 5 times 0, 0. 5 minus 5 times 1, so 5 minus 5 is 0. Negative 10 minus 5 times 8. So negative 10 minus 40 is negative 50. And then 0 minus 5 times negative 10, 0 plus 50 is 50. So that takes care of column 1 and column 2. Now we're just working on column 3. Once we get to column 3, the only step we can do is the multiplication or division of that row by a constant, which is nice in this case because we have a negative 50 here and a 50 here. So to make this into a positive one right here, we'll take row 3 and divide by negative 50, and that'll give us a new row 3 to work with. Excuse me. Now, negative 50 divided by negative 50 is positive 1, and then 50 divided by negative 50 is negative 1. Okay, we're almost done with this problem. We have our 1, we have 1s where we want them, we have these 3 zeros where we want them, we have that 0 where we want it, so now we just have to zero out these last two terms here. Now for these two, we always just want to use this last excuse me. we're going to use this last number here. So for row 2, for instance, we have an 8. I heard my dog start barking in the other room, so he probably thought it was someone outside the house or something. I don't know. He's real jumpy. Anyway, so 8 and 1. So if we can take row 2 and subtract row 3 8 times, 8 minus 8 of these would give us a 0. So we'll do row 2 minus 8 times row 3. Replace row 2. And at the same time, we want to make this 11 into a 0, so we want to take 11 minus 1 11 times. So row 1 minus 11 times row 3 will replace row 1. So if we take 11 minus 11 times 1, that gives us the 0 that we want there. So row 3 is unchanged. For row 2, we take row 2 minus 8 times row 3. So 0 minus 8 times 0, 0. 1 minus 8 times 0 is 1. And then 8 minus 8 times 1, 8 minus 8 gives us 0. Negative 10 minus 8 times negative 1, so negative 10 plus 8 is negative 2. And then 11 minus, now row 1 minus 11 times row 3, replace row 1. 1 minus 11 times 0 is 1. 0 minus 11 times 0 is 0. And then 11 minus 11 times 1, 11 minus 11 gives us 0. And then negative 8 minus 11 times negative 1, negative 8 plus 11 gives us a 3. So our conclusion is x is equal to 3, y is equal to negative 2, and z is equal to negative 1. And so that combination of numbers is a solution to all three of those equations. Any questions on that? Okay. It might be good to go back and try to solve two equations with two variables this way, just to maybe get a little more comfortable with the matrix approach. if we look at it from this point of view, I mean, we know how to solve that using different methods already. Supposedly, I couldn't figure out just now when I was trying it, but there should be a way to use the calculator to solve these. If you have your calculator manual still, then that might have some instructions in there for you. Yeah. Now, the principle here is the same. You know, we still want to get a 1 here and then a 0, and then a 1 here and then a 0 above it. So here, 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 here. And it might be a nicer way to practice these concepts, working with just 2 rows instead of 3. So, if we have, how would we go about getting a 1 in the upper left? What's a good way or a good approach we can use to make that into a 1? R1 minus R2. Good. Yeah, because if we can just take this 3 and subtract the 2, that'll give us a 1 right there. Now, notice we're not changing row 2, we're only changing row 1. So 3 minus 2 is 1. 2 minus negative 5, so 2 plus 5, 7. And 2 minus 14 being negative 12. Okay. Next step, we want to make this into a 0. How could we zero out this 2? We can't just subtract 2 from a row. Yeah, we can't just subtract 2 from everything because I think y'all are on the right track though. What's actually happening here is that the x, the y, and the constant are still present. But we can't just subtract 2 from x, 2 from y, and 2 from the constant and have the equation still be the same equation that we started with. So it's not we're not able to just subtract or add to a row by itself. And again, our 3 operations, we could switch 2 rows, which we wouldn't want to switch these rows right now. We could multiply or divide a row by a number, which that doesn't help us here either. When we're trying to get a 0, we really just have to use that third technique, which is to add or subtract one row to another. So we can never just say minus 3 or plus 2 or anything like that. We could multiply row 1 by a number and then combine that with row 2. That's a possibility. We can't just subtract a number from a row. But it's good. It's good that we're working through this and figuring out what we can and can't do. So does that give you any insight into the correct step here? It is true that we need to figure out a way to subtract 2 from this number, but we have to let the rows interact with each other to do that. Row 1 times can't multiply 2 rows either. That's not a valid operation. We can multiply one row by a number by itself, and we can add 2 rows or subtract 2 rows or a multiple thereof. We can't just multiply 2 rows either. There we go. Row 1 times 2 minus row 2. Good. So we can multiply row 1 by 2 and then subtract the row 2, which means for at least for this column, we'll be doing 2 times 1 minus 2, and that will give us a 0. But then the same combination of operations will have to happen here and here and then here and here. Okay, so I was writing over here. Again, these are our 3 operations that we can do. We could switch 2 rows, which in 2 equations it shouldn't really come up other than the first step. We multiply, divide a single row by a constant, or we can add or subtract 1 row and a second row from each other. And then we can repeat that, which means we could actually add a multiple, take a multiple of 1 row and add that to another, or subtract a multiple of 1 row from another. Okay, and that's what we talk about right here. If we take 2 times row 1 and subtract row 2, we'll be able to get that 0 that we wanted. So row 1 is actually unchanged here. And we'll take 2 times row 1 is 2, subtract row 2, 2 minus 2 gives us a 0. 7 minus 2 times negative 5, sorry, I got it backwards. 2 times 7, because 2 times row 1, 2 times 7 is 14, minus negative 5, so 14 plus 5 would give us a 19 there. And 2 times negative 12 is negative 24. Subtract 14. So negative 24 minus 14 is negative 38. Okay. How are we going to get this one to be a 1? We got 1 and 0. Now we need a 1 here. And for this one, we don't want to use row 1, because if we utilize row 1, that will change the 0 that we already worked so hard to get. So at this stage, if we're in the bottom row, we just want to make it a 1 there. Best way to do that is to multiply or divide by a number. So what can we do on row 2 to make that into a 1? R2 divided by 19. Okay. And this actually works really well because 38 is a multiple of 19. It's actually 2 times 19. So 0 divided by 19 is still 0. 19 divided by 19 gives us the 1 that we want. Negative 38 divided by 19 will give us a negative 2. So one last step here. We want to take that, we have that 7 in row 1, and now we want to make it into a 0. And we'll need to use row 2 for this. So we're using both of the rows, row 1 and row 2. How do we make that 7 into a 0? Seven times row 2 minus row 1. It's very close. It might be better to say row 1 minus 7 times row 2. And the reason I would switch that order is if we did row 2 minus row 1, 7 times row 2 minus row 1, that would actually turn that into a negative 1. We want it to stay a positive 1. That's the only difference there. So we should always start with the row that we're beginning with, R1, and then modifying it according to what other row we're working with, which is row 2. So row 2, unchanged. So we leave it as it is. So we take row 1 minus 7 times row 2. So 1 minus 7 times 0, still 1. 7 minus 7 times 1, 7 minus 7, 0. And negative 12 minus 7 times negative 2, negative 12 plus 14 gives us a positive 2. And so from there we can say x equals 2 and y equals negative 2. Okay. And graphically that would represent the point of intersection of the two lines. Any questions here? Okay. Hopefully that the last step right here, or this step, where we find the x and the y. Oh, yeah. Well, I mean, that's actually all of it right there. Third principle is we can add and subtract one row and the second row. So basically, what we just did in this last step up there. Oh, I got you. Sorry, Geneva. Okay. Mm-hmm. Yeah, in this last step here, again, we wanted to make this a 0, and so we needed to use the 1 to do that. So if we can take our 7 and subtract 1 7 times, 7 minus 7 would give us the 0 that we need. Okay. Now, when you said row 1, or sorry, 7 times row 2 minus row 1, that would work. That would give us a 0. But 7 times row 2 minus row 1 would actually make this a negative 1. And we don't want to change that one, if possible. So, but yeah, we want to start with row 1, 7, and subtract 7 times row 2, 1. 7 minus 7 does give us our 0, and then we change the other two accordingly. Okay. Alright. Like I said, I do hope that's helpful, both looking at the 3x3 and the 2x2. I know it's not an easy topic, and the main thing I can say is just keep practicing it. And especially if you have, like in your textbook, if you look in the back, even on the ebook, it should have the appendix where it shows you the answers to the odd problems. You can just, if you're working problems out of the book, you can just find one, work it out, and work out an odd problem, and see what you can do with that, and see if you can get it equal to the answer that they have in the back of the book. But yeah, it does require practice, especially a topic like this, because it requires one insight as far as how we're going to combine these different numbers together to get the desired number. And again, our goal in these problems is, if it's just two equations, our goal is to get it 1, then 0, and then 1, and then 0, just working around this way. And if we're in 3 equations, we still want to get a 1 here, then 0 out the 2 terms beneath it. Get a 1 here, 0 out the terms above and below, and then get a 1 here, and then 0 out the 2 terms above. And just create this situation where it's just the answers on the right now. X equals A, Y equals B, Z equals C. Okay. So as long as we know what goal we're working towards, we can try to manipulate the matrix and get to that point. But again, we only have 3 different operations that we could really use. Alright, well, you all have a good rest of the day, and today's Wednesday, so have a good weekend also, and take care, and we'll continue this wild ride on Monday. So, have a good one all. Bye.